So our next chapter are irrational numbers. So what are irrational numbers? Irrational numbers are those which can neither be expressed as a terminating decimal number or a repeated decimal form. So that means irrational number generally does not fall in the set which defines a number in the form p by q. So p by q is a generic form of rational number. Something that does not fall in that bracket, that set, should be called an irrational number. Now, there are exceptions like 22 by 7. It has a very special notation, pi. This is in the form of p by q, but is an irrational number. Now, other than that, all the other criteria of being irrational numbers are followed by this value pi. So in general, let's say if you have a number 1.4142357 and so on, where it does not terminate or it does not even become a repeating decimal. All these are examples of irrational numbers. A very common set of irrational numbers are roots. So when you find nth root of an integer, they are irrational numbers unless there are very specific cases. So let's say we are going to find second root of 9. The second root of 9 is basically written as square root of 9 is 3. Now when I said nth root is that, if I say that nth root of x is y, that means x is equal to y to the power n, or y being multiplied onto itself for total n times. From this definition, if we try to figure out what is y should be written as nth root of x. Now in general, lot of your irrational numbers will fall in this place. So square root of 2, square root of 3, these are irrational numbers. Now what happens when you do mathematical calculations involved with irrational numbers? Let's say square root of 3 is an irrational number. Now that added with a rational number 2 is still an irrational number. Similarly, 2 minus root 3 is also an irrational number. But what happens when you add this two? So 2 plus root 3, your first irrational number added with 2 minus root 3, it results in 2 plus root 3 plus 2 minus root 3, that is 4, because plus and minus of root 3 cancels each other, and that is a rational number. Similar to that, 2 plus root 3 multiplied by 2 minus root 3 will finally become 2 square plus 2 root 3 minus 2 root 3 minus root 3 square, that is 4, plus these two cancels each other, 4 minus 3, which is 1. So I will explain how exactly this amounts to 1, or what is the other easier formula to reach this value. But as of now, what I try to explain is that multiplication and addition or any other mathematical operation as such between two irrational numbers do not guarantee the production of an irrational result. On the flip side, if you do addition between a rational and irrational, your result is an irrational number. Subtraction between rational and irrational results in irrational number. Rational number multiplied by irrational, the result will be irrational. Rational divided by irrational, the result will be irrational. So now, to draw a closure to the number systems, let us introduce real numbers. So what are real numbers? Real numbers represent each point on the number line. To put it in a simple way, real numbers constitute of rational numbers and irrational numbers. So by definition, a real number will either be an integer or is a terminating or repeating decimal representation, or it is a non-terminating and non-repeating decimal representation. So this definition basically encompasses entirety of rational and irrational numbers. And please keep that in mind, whether it is rational or irrational, a real number will always be representable on the number line. Now this brings to the next question. If we have real numbers, is there something called unreal number? Yes, there is. We do not call them unreal numbers, we call them as imaginary numbers. So what are imaginary numbers? Imaginary number is defined as any order of root of a negative integer. That is your imaginary number. So the basic imaginary number is square root of -1. Now let me explain this a little bit more. So we all know that if we go ahead in the opposite direction of finding a square root, let's say we try to find the root of a particular number. Just like we explained that if we need to figure out the nth root of x, we kind of started from x equal to y to the power n. Similar to that, if we want to figure out what is the number, let's say x is the number, which multiplied by itself will produce you a value of -1. If this holds true, then we can safely assume that square root of -1 is x. Now, in reality, on the natural number line, you will not find an x, which can be multiplied onto itself to produce -1. This is an imaginary number. So this square root of -1 multiplied to any number, any real number, will produce an imaginary number.